Hello everyone, my name is Paige Mercer and this is going to be my presentation on bollworm. So you might be asking, what is a bollworm? A bollworm is a caterpillar in the genus I'm going to mess this up, Helicoverpa. In North America, it's the most common species of it being the cotton bollworm, but there are different types of bollworms. There is the Old World bollworm, which is more common in Europe and spread through parts of Asia, Africa, and Australia. But there's also the cotton bollworm, which I'm going to be focusing more on. Um, but it's going to be more common in North America, Central America, and South America. They cause major economic damage because they attack crops such as cotton, corn, tomatoes, soybeans, peppers, and so many other plants. And these pests can really contribute to a lot of crop loss, and it reduces crops yield and its quality of the crop, and thus makes them a very serious agricultural problem. Biology and life cycle. The bollworm is an invertebrate, which means it does not have a spine. Um, so it goes through four different life stages. This one specifically, it goes through the eggs, larva, pupa, and then adult moth stages. The egg stage, most female moths lay the eggs directly on the plants. Then they continue to hatch, and then they hatch within 2 to 5 days or so. From there, they start feeding. Um, in the larva phase, after they start hatching, they become caterpillars, and this is where the feeding and the damaging stage start of the life cycle. They'll feed for about 2 to 4 weeks, and they'll be eating different reproductive tissues on the plant. So it's flowers. Typically, that's what they'll target is their flowers. Um, and then once they're fully developed as a caterpillar, they become a larva. They start to go to the soil and move around underground and go through pupation, become a pupate in the soil, a pupa in the soil, and then during the stage they develop into adult moths. Adult stage after the pupa stage is when the adult moths will emerge from the soil, mate, and then begin reproducing for the next generation. Female moths will lay between 500 to 1,500 eggs during their lifetime, and they end up um, mating right after they emerge out of the soil. And then multiple generations can occur each year, which makes it so that a lot of problems are reoccurring because multiple generations can occur each year in warm climates. So the offspring of the parents will be able to damage right after the parents, which can cause a lot of economic loss. I did not mean to name this slide to key topics, but this is my slide on its environment. So ignore that and make it say environment. Bollworms typically prefer agricultural fields, specifically, like I was saying, with flowering crops. They're most commonly found in cotton, corn, and vegetable crops, with a list of host plants being cotton, corn, tomato, soybean, pepper, okra, sorghum, tobacco, and beans. Um, yeah, those are going to be the most common for um, them to be noticed in. And a lot of those are actually in the nightshade family, so they tend to prefer things in the nightshade family to eat. So, damage caused by bollworms. Over here, we have a photo of a plant that's split open, and it does have a bollworm inside. And I believe that's a cotton boll. Correct me if I'm wrong. It could be absolutely anything else, but you can see the white where the fiber would be up in the top left. And this is examples of what damage can be done by bollworms. It had burrowed into it and then started to eat the inside. If a cotton like this was processed, it could lead to a lot of different things, a lot of economic loss because the fiber would be too dark, and the darkening of the fiber makes it less quality. And if it's all getting magenta together, you're going to have dark patches in your cotton. So the damage is caused by chewing and boring into fruits, flowers, and reproductive plant structures. So feeding reduces crop yield and crop quality, like I was saying. Specifically in cotton, it can cause brown patches in your cotton lint. Um, and then also the wounds that are created by these caterpillars can often lead to bacterial infections, mold growth, and it reduces the profitability and marketability of the produce. So physical controls. Um, Mechanical control is physical control. Damaged fruit can all be removed by hand. You can also use pheromone traps in order to monitor the moth population, and this can determine how deeply affected your crops are. Um, and then between seasons, if you don't have anything cropped, if it's an annual, you can use soil tilling. This will kill the pupae that are developing underground during the winter. Biological control is next. Biological control, several people use ladybugs, spiders, birds, and certain parasitic wasps in order to attack and destroy bollworm eggs before they hatch. So typically, those are the species that are used, and then that's a picture of a bollworm's feeding on a piece of corn. Typically, ladybugs, spiders, and birds are used as the biological control because they're natural predators to help control the bollworm. The next thing I wanted to talk about is bacillus. Some people discovered that plants are treated with soil bacterium, Bacillus thuringiensis, is toxic to bollworm larvae. Specifically, this was found. I'm forgetting, but you can have BT cotton and BT corn, and this bacillus gene will kill the bollworms because they are not they are very susceptible to it. This can kill the bollworms while reducing the need for insecticides by planting those genetically modified GMO Bacillus BT cotton. Chemical control, pesticides. So chemical insecticides are commonly used, but the thing is that since they're so commonly used, a lot of bollworms have actually developed a resistance because of the repeated exposure. To do this, to spray effectively, your best bet is to rotate the different chemical classes and only spray when necessary, and use some of the other methodology that I've described. So cultural control, chemical control only when needed, um, biological control, all these different methods um, in order to help prevent plant resistant diseases. And then also looking at the economic threshold, how much of this pest is actually going to damage the product and make it a worse cause than having to apply pesticides. So looking at how much damage the crop is going to take versus how much it's going to take to um, apply pesticide. So next I have cultural control. Cultural control, you can typically use crop rotation. So this will disrupt the bollworm's life cycle because it's used to feeding on, like I was saying, some of the nightshade plants, so tomatoes, bell peppers, even cotton, And so since they're typically found on those types of crops, rotating the crops will prevent these bollworms from getting to their preferred habitat, which can prevent them from reproducing. So going after and doing like a cole crop, like a kale or a lettuce. Lettuce isn't a cole crop. Um, but you can doing something like that instead of one of their preferred species. You can use crop rotation in order to lower their population. So crop sanitation, more specifically, it's not really sanitation. It's more of removing the debris. So the plants that had died on the vine, so say tomatoes, if they had died on the vine, make sure you can remove that type of vegetation because a lot of times that's where bollworms will hide and just snack on that one piece. And so it can also increase your chances of getting mold and bacterial problems. Planting time, you can also theoretically adjust your planting and harvest times in order to avoid the peak bollworm season. This might not work in every case, but it's a good thought to have. And then you can also plant the bacillus resistant varieties. So BT cotton, BT corn, plant those resistant crop varieties so they'll help reduce the damage. So, in conclusion, bollworms are serious agricultural pests. Their rapid reproduction and broad host range and ability to develop pesticide resistance make them really difficult to manage. And then using an integrated pest management system, an approach that combines both biological, cultural, mechanical, and chemical methods to stop crop damage and provide um, improve your sustainability is how that is really going to work effectively. And it's how we can preserve our environment by not using chemical controls as often and um, helping to improve on pesticide resistance and runoff. So this is going to be my list of references. And then if you have any other questions, feel free to shoot me a message. Thank you so much for this semester. I really appreciate your teaching.